Today we'll be doing reflections. Okay, so again, like I told you on the last one, most of the discovery and stuff in practice will be done in class, okay? But I just want to make sure you have down what you were supposed to get out of our discovery. So it's many ways you can reflect on a coordinate grid or off a coordinate grid. But there's four main ones that they like to use. So those are the four that we're going to use. Alright, so we have across the x-axis, across the y-axis, across the y equals x, and across y equals negative x. So I'm going to describe the rules for these things, but I'm also going to explain them, okay? So give me 1 second. Alright, so some stuff I'm going to just show you an example, and then the part I write out, that's the part I want you to write, okay? So reflection over the x-axis. So, this is my x-axis here. Sorry. Okay, so let's say my first point was at 2, 3 here. So if I wanted to reflect over the x-axis, I need to see how far away I am from the x-axis and go the same distance in the other direction. So I'm 1, 2 away. So I do the same thing in the other direction, 1, 2 away. So right here. And that point would be, oh, I made a mistake, y'all. Hopefully y'all caught it. I love when I make mistakes because I hope that you catch them before we go too far. Okay, so this was actually at 3, 2. Alright, so again, same thing. I'm going 2 away, so I'll go 2 away the other direction. So this was at 3, negative 2. So what's the difference between the pre-image, and the image? Okay, so from 3 to 3, I didn't do anything. My x's didn't change, but my y's, the sign changed. Okay, so when I cross the x-axis, my y sign changes. Okay, so across the x-axis, you have, so this is what I do need you to write down. If you have your original xy, then that goes to, when you cross over the x-axis, to positive x, negative y. The y doesn't necessarily have to be negative, that just means that the sign is going to change. Okay. Alright, so now let's look. Oh, so then I want you to put a little example underneath it. So if you had 3, 2, when you reflect over the x-axis, it will become 3, negative 2. Okay. Alright, so an example for across the y-axis. Let's say I was at negative 3, positive 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4. Okay, so let's say that's my point. Negative 3, 5. So if I reflect over the y-axis, I need to see how far away I am from the y-axis. I'm over 1, 2, 3, so I go the other same direction. 1, 2, 3. So my new point is at 3, 5. So in this case, all that changed was the x sign changed. So that's what my rule is going to be. Alright, so this part I do need you to write down. So when you reflect over the y-axis, the x sign changed, the y sign stays the same. So for example, if you had negative 3, positive 5, you would have positive 3, positive 5. Okay, so that just means the sign changes. And now we're going to reflect over the line y equals x. Y equals x is a line. Remember when we talked about y equals mx plus b, and b is the y-intercept, and m is the slope. So y equals x has no y-intercept, so it goes through 0, 0, and the slope is 1 over 1. 1 over 1 and 1 over 1. So y equals x looks something a little better, but like that. So when you're reflecting over that, so let's say negative 2, negative 2, positive 3. Let's do that. you would have to do a perpendicular distance away. So from here to here, from y equals x. And then you have to do the same thing over here. Okay? So, it would be, it would actually be here. Okay. It's hard to do when your line isn't perfectly straight. Okay? And it would be a negative, not negative 3. It would be a 3, negative 2. So notice the only difference between here and here is that the x and y switch places. Instead of in negative 2, 3 is 3, negative 2. Okay? So that means our rule is when you reflect over the y equals x, the x and y switch places. So example, if I had negative 2, 8, and I reflect over y equals x, it would be 8, negative 2. Okay, y equals negative x is pretty much the same, except it goes the other direction. And let's say I was at 3, 4. I would still go the perpendicular distance away from that y equals x and go in the same direction. Again, it needs to be a better line. So I would end up at 1, 2, 3, 4. 1, 2. I end up there, which is at negative 4, negative 3. So notice in this case, the x and y switch places again, but both signs change. Both signs change. So in this case, when you reflect over y equals negative x, the x and y switch places and they both signs change. So example, if I was at 3, negative 4, and I reflect over y equals negative x, I would be at 4, negative 3. Alright, that's the main part with reflections. Talk about rotations next. Hello? What? Nigga, who you talking to? I'm the grown up. By my house? Okay. Yeah, I ain't never seen it in person. Okay. Yeah, text me on mine. I know her name, I just ain't never seen her besides on the picture. And schoolwork. Well, I got stuff to do prepare for school. And then I'm a teacher, and then I'm a student, so I have to do my homework. I can't do it. Let I finish these videos. Huh?